One, remember today we discussed about some basic concepts related to test of hypothesis, but we still have to discuss about a few concepts. Remember, we talked about a game, flipping a coin. You tossed a coin, and it is assumed that the coin is fair in the beginning. When a coin is tossed, there are two possible outcomes, head and tail, but when a fair coin is tossed, the probability of each event is 0.5. In this game, you will win 10 rand if the outcome is a head, and you will lose 10 rand if the outcome is a tail. And we discussed that this game is a fair game because the expectation of income from this game is 0. Then after a while, you realize that there is something's wrong. When you lose money, you get suspicious and you have a question in your head. Is the coin really fair? You start to claim that the coin is not fair. A statistical hypothesis is a claim or assertion either about the value of a single parameter, about the values of several parameters, or about the form of an entire probability distribution. Here in this game, the assertion is about the value of the parameter, the probability of success or the probability of head in Bernoulli distribution. And also I told you that this chapter is important because in addition to chapter 9, in chapter 10, 11, 12 and 13 we are dealing with hypothesis test. Okay, hypothesis testing is a form of statistical inference that uses data from a sample to draw a conclusion about the population parameter or population probability distribution. It means in any hypothesis test, we need sample to make decision. In fact, we need sample to gather evidence to see if the claim is true or not. In any hypothesis testing problem, when there are two contradictory hypotheses, the null hypothesis H0 is the claim that is initially assumed to be true. Remember that in the beginning we assume that the coin is fair, and the alternative hypothesis is the assertion that is contradictory to H0. But question, what are H0 and HA in our problem? Okay, in the beginning we assume that the coin is fair. It means H0 is the probability of success, or the probability of observing head is equal to 0.5. But after a while, by using money, we came with a claim that the probability of success or the probability of observing a head is less than 0.5. Okay, the first step in hypothesis test is formulating H0 and HA. Remember I told you that there are three different kind of hypothesis tests in statistics: left sided or left tailed test, right tail test, and two tail test that you can see here. Here H0 is theta is equal to theta 0. and if the alternative has this shape in number 1, theta is greater theta 0, it's called as um, right tail test. Theta less than theta 0 is called as left tail test, and theta is not equal to theta 0 is called as two tail test. And we have 4 rules to formulate H0 and HA. We always should use or must use the notation of the population. Null hypothesis must always contain the equal sign. Alternative must never contain the equal sign, and the hypothesized values theta 0 must be the same in both hypotheses. You can see here that H is theta is equal to theta 0, and again in all of these alternative hypotheses we have theta 0. So I mentioned that HA is referred as the research hypothesis because it's the claim that the researchers would really like to validate, and the null hypothesis, or the word null, means that no value, no effect, or no consequence, which suggests that H0 should be identified with the hypothesis of no change, or no difference, or no improvement. We also went through these 3 examples. The first example, for example, the average of shelf life of dried fruits will be increased with new additive. In the past, the average of shelf life of dried fruits was 200 days. So initially, or in the beginning, the notation of the mean for population, mu is equal to 200, but by using new additives, now the average of, or the mean of shelf life is greater than 200, and it's a kind of right tail test. Again, a refrigerator is still the same quality as in 2010. Proportion to be replaced under warranty in 2010 was 0.1. So in the past, the proportion, the keyword, look at the keywords, the proportion means the probability was 0.1, but we want to see if it's still the same or not. It means it's still equal to 0.1, or it's not equal to 0.1. It's a two-tailed test. And example 3, variation in battery lifetime seems to be reduced in new release. Lifetime before known to have a variance of 10 hours. So in the past, the variance, okay, again look at the keywords, variation or variance, it means sigma 2 in the past was equal to 10, but now, and the variations in battery lifetimes it seems to be reduced, so now the variance is less than 10, so it's a kind of left tail test. And also remember, we went through these 2 exercises. You can again do it. You can again do these exercises to practice more. And then the null hypothesis will be rejected in favor of the alternative hypothesis if and only if sample evidence suggests that H0 is false. Remember, we should be more supportive for H0. It means, it says that if the sample does not strongly contradict H0, we will continue to believe in the plausibility of the null hypothesis. So and look at here, the initially favored claim, it means H0 will not be rejected in favor of the alternative claim unless sample evidence contradicts it and provides a strong support for the alternative assertion. So to reject H0, we need a strong evidence. So we always support H0 unless sample evidence contradicts it strongly. So the two possible conclusions from a hypothesis test are reject H0 or fail to reject H0, and we remember we never use accept. Reject H0 or fail to reject H0. Let's back to the game. You claim that the coin is not fair, and it is obvious that because I want to support H0, I don't want to accept your assertion unless and until you can provide strong evidence of your evidences of your assertion. So what can you do? Remember, you need evidence based on a sample. After formulating H0 and HA, the second step is finding a test statistics. A test statistic is a function of the sample data on which the decision is to be based. So we need a function based on the sample. We will use this function to make decision. It means to make decision about rejecting H0 or not rejecting H0. Let's back to the example, to the game. Let's X, a random variable here, as a test statistic, is the number of heads in 100 coin tosses. The number of the heads in 100 tosses give us some information about the probabilities. It's obvious because according to the definition of the probability is the number of observing heads divided by 100 here. Okay, it's the probability of heads. So the probability of heads is the number of the heads divided by number of the tosses. So the number of heads determine the probability of heads. So this test statistics will help us to make decision about the hypothesis. The next step is finding a decision rule. X, the number of heads, has binomial distribution. So we have a test statistics. This is step 1. In step 2, we have test statistics or random variable. Here is the number of heads. In 100 tosses. Okay, X has a binomial distribution, the number of the success. So if H0 is true, X has binomial distribution with parameters 100 and the probability 0.5. if H0 is true. So the expectation of X is NP is 50. So if H0 is true, we expect roughly 50 heads. But if H1 is true, we expect less, because the probability of success or the probability of head is less than 0.5. So if H1 is true, we expect less than 50. So X has binomial distribution. If H0 is true, X has binomial distribution with parameters 100 and 0.5. Then the expectation of X is 50. It means we expect roughly 50 heads if the coin is fair, and we can expect less than 50 if the coin is not fair. A value X just a bit below 50 does not strongly contradict H0. We need strong evidence. So it is reasonable to reject H0 only if X is substantially less than 50. So for example here, one such test procedure is to reject H0 if X, for example, X is less than 40, and not reject H0 otherwise. So we make a decision rule now. What is the decision rule? Okay, if X is the number of heads for any X less than 40, we reject H0. This is the decision rule. Step 3. So a test procedure is a rule based on sample data for deciding whether to reject H0. A test procedure is specified by the following. 1. A test statistics, a function of the sample data on which the decision is to be based, and a rejection region is the set of all test statistics values for which H0 will be rejected. So again, look at this example. X is the number of heads in 100 tosses. What are the possible values for X? Sx. Okay, the number of heads can be 0, can be 1 out of 100, 2, 3, 99, or 100. In fact, we divided this space into two different sets. One set different subsets. One is which is shows the values less than 40, and then 40, 41 to 100. So which shows the values equal to 40 or greater than 40. We call this subset as rejection region, because for any values in this subset, we will reject H0. If we observed any of these values 0, 1, 2, 39, we will reject H0. Look at this sentence again. Is the set of all test statistics values for which H0 will be rejected. So there are the values for which we have to reject H0. The null hypothesis will then be rejected if and only if the observed or computed test statistics value falls in the rejection region. And the final steps is making the final decision. So we formulated H0 and H1. Then we have a test statistics, we have a decision rule, and now we need to make the final decision if the coin is fair or not. So according to the test statistics, you toss the coin 100 times to record the number of the heads, X. For example, suppose that X, we observed X, the number of the heads, for example 37. Then if the observed value of X falls in the rejection region, it means if the X is less than 40, H0 will be rejected. So look at here again. 37 is less than 40. It means the value of X falls in the rejection region. So their final decision or the final results is reject H0. But suppose that we toss a coin 100 times and the number of the heads is, for example, 55. So 55 is not in the rejection region, so it means it's greater than 40. So the result is fail to reject H0, or there is not enough or sufficient evidence to reject H0. Otherwise, there is not enough or sufficient evidence to reject H0. You can also remember this sentence in your mind to keep it in your mind to use it. We can use reject H0, or there is not enough or sufficient evidence to reject H0. Now look at another example. Suppose that 10% of computer boards produced by a manufacturer is found to be defective. So X is the number of defective boards, and P is proportion of defectives of probability of defection. So there is a claim. Engineer improved process to yield fewer defects. It means, okay, initially or in the past, 10% of the boards was found to be defective, but it means the proportion was equal to 0.5, but now they improved the process and now we have fewer number of defects. So now the proportion is less than 0.1. Again, we have a same as the game, the flipping a coin problems. We have a left tailed test, so we need a sample. So we have 200 boards. We record the number of the defectives. Again, the number of the defectives has binomial distribution with parameters 200 and 0.1 if H0 is true. So the expectation of the defectives, the number of the defectives is 20. So it means if H0 is true, we expect roughly 20 defective boards, but if H0 is not true, we expect less than 20 defective boards. It means, for example, here we can assume that about 50 or 40 to make our decision rule. So again, in this example, step 1, formulating H0 and H1. Okay, H0 in the past, 10% of the boards were defective, but now we improve the process and this probability is less than 0.1. Step 2, we need a test statistic. The test statistics is number of defective boards in 200 boards. Step 3, we need a decision rule. Okay, the number of defectives in 200 boards can be 0, 1, 2, 3 to 200. So if H0 is true, the number of defective boards X has binomial distribution with parameters 200 and 0.1. So expectation of X is 20. So if H0 is true, we expect roughly 20 defective boards. But if H1 is true, because the probability is less than 0.1, we expect if h1 is true, again we expect less than 20. So we can write our decision rule as this. For example, if x is less than 40, for example, we reject h0. Okay, thank you. In the next session, we will talk about the errors in hypothesis test. On Wednesday, you can watch video 2 about errors and risk in hypothesis test.